Hi everyone, we're going to go through simplifying fractions today, so let's just hop into our example. The first example is a problem that looks like this. That says 10h squared plus 7h over 10h plus 7. Now looking at it, we don't see anything that divides out right away, but the trick here is to use factoring to then find some common things that we can then divide out. So if you look on top, we do have h's on top. So we're actually factor out that h, and we're left over 10h plus 7, right? If you double check, that's h squared and 7h. And then we're going to divide that by 10h plus 7. And you can see, whoa, we have a 10h plus 7 on top and a 10h plus 7 on bottom. Since these are exactly the same, we can then divide them out. Okay, and we're left with just the letter h. Okay, so sometimes our values aren't obvious what they're going to divide out, but using factoring, that does help. Another common type of problem we see is when we see problems that are trinomials, quadratics, and then we can see, here's an example of p squared plus 24p plus 44 over p plus 2. In this case, it's again not obvious what divides out. You can't just divide the p's, right? We don't divide like 107 divided by 10 and say, oh look, the 10s divide out just because you have numbers that look alike. So it turns out we're going to go ahead and factor the top. Let's think about numbers that multiply to become 44 that add up to become 24. So that could be 4 and 11. That could be 2 and 22. Oh hey, 2 and 22 multiply to become 44 and add up to become 24. So let's go ahead and factor that. So we have in the front and back p, and we said 2 and 22. And since we see plus plus, we're going to go ahead and use that as a plus plus for us. And a p plus 2. And you can have a hint on the bottom. You can see that we have a 2 on the bottom, so there's probably going to be a 2 hidden in there if this was actually factorable. And now we have a common factor that we can divide out. Here we go. P plus 2 divided by p plus 2. And we're left with p plus 22. So you can see sometimes we just have to factor that trinomial, and that'll give us something in common that we can then divide out. Well, let's flip it around and let's look at the trinomial on the bottom. And let's say it's z plus 3 here over z squared plus 11z plus 24. And again, you can see that we can't just divide out the z's, and we can't just divide out the 3's. That's not how we're going to factor these. That's not how we're going to simplify these. So let's go ahead and see if we can factor the bottom. Two numbers that multiply to become 24 that add up to become 11. You're probably yelling at me saying 3 and 8 already, but that's right. 3 times 8 is 24, and they do add up to become 11. So let's rewrite that z plus 3. And in the front and back, we're going to say z, 3 and 8, and plus plus. And of course, remember, you can take that hint that there's a plus 3. We're probably looking at a plus 3 there if this is factorable. So perfect. We do have that common z plus 3, right? Z plus 3, z plus 3. So we can go ahead and divide those out. Gone. Now, oftentimes the mistake is that now that you see a z plus 8 left over, we're just going to leave that alone. But remember, that's on the denominator, so we want to leave that on the denominator. Because that doesn't go on top, it's still the fraction that z plus 8 is on the denominator. Let's go through another example. Here's a bigger problem. We'll write it as 16q cubed plus 40q squared plus 25q over 4q squared plus 25q plus 25. Okay, now this one looks like a crazy mess. Looks like, how am I supposed to solve this problem? How am I supposed to simplify it? Well, let's just take a look at the top and we'll see some stuff in common. So let's see. I see a bunch of q's here. So maybe I can do something about those q's. So let's go and factor out those q's. We'll take the q out of the top, and we'll say it's 16q squared left over plus 40q plus 25. On the bottom, we're going to have a 4q squared plus 25q plus 25. And let's see, what else can we do? Can we divide anything else out? I'm able to factor out the bottom numbers. Let's see, 2 and 2, and this is 5 and 5. And if I multiply them together, that'll be 10 and 10. That doesn't add up to become 25. Let's try 4 and 1 and 25 and a 1. Okay, so those are my other options. But if I multiply the 4 and the 5, that gives me a 20. And the 1 times the 5, that will give me a 5. Hey, so this is factorable. So the denominator could be, we said 1q and 4q. The way I teach factoring, we multiplied 1q by a 5, and then it's going to be 5 plus plus. And that gives us a 20, and 5q gives us our 25q. Let's take a look at the top. Let's see if the top is factorable. Maybe we'll have a 4q plus 5 on top. That seems like it's a possibility. 4, 4, 5, 5. 4 times 5, and 4 times 5 is 20, and 20 plus 20 is our 40. That looks great. So we're going to rewrite this as q with 4, 4, 5, 5, plus for the q, plus plus. Okay, so let's go ahead and copy those over. Oops. I should duplicate. We'll take that over here. Okay, we're going to duplicate this guy over here. So this is our new fraction. And you can see values are going to for sure cancel out, divide out here. So we have q, our 4q plus 5 on top and bottom. So those divide out. The 4q plus 5 and the q plus 5 are not exactly the same, so those aren't going to divide out. So we're left with q 4q plus 5 over q plus 5. Definitely a harder problem, but you can see if we factor out our common values and then factor out our trinomials, we're able to then look for some common factors to divide out. That's it.